The National Electrical Code, abbreviated NEC, does not specifically provide demand factors for car washes. However, the NEC does offer guidance on determining demand loads for installations where not all equipment operates simultaneously. NEC Article 220.87 includes an informational note. It states for installations where the maximum demand for the equipment is less than 100%, the authority having jurisdiction having special knowledge of the installation may grant permission for the demand factor to be used to adjust the maximum demand. ASHRAE Standard 202, titled Energy Efficiency Standard for Low-Rise Residential Buildings, provides demand factors for various building types. This includes car washes. According to Standard 202, the demand factor for car washes is 60% for car washes with automatic equipment and 40% for car washes with manual equipment. To determine the demand load for a car wash, firstly, identify the connected load. Calculate the total wattage of all motors, pumps, and other equipment used in the car wash. Secondly, apply a demand factor. Based on the type of car wash, if it is automatic or manual, and the information provided in ASHRAE Standard 202, apply the appropriate demand factor to the connected load. For example, if the connected load is 50 kilowatts and the demand factor is 60%, the demand load would be 30 kilowatts, calculated as 50 kilowatts multiplied by 0.6. Thirdly, consider seasonal usage. Adjust the demand load if the car wash is only used for 6 to 8 months of the year, depending on climate. For example, if the demand load is 30 kilowatts but the car wash operates for only 6 months, the adjusted demand load would be 15 kilowatts, calculated as 30 kilowatts multiplied by 6, then divided by 12. Once the demand load has been determined, the electrical service can be sized accordingly. The service size should be large enough to handle the peak demand of the car wash without overloading the system. This typically requires consulting an electrician or electrical engineer for professional guidance to ensure compliance with all applicable codes and safety standards. When calculating the electrical service size for a car wash, it is important to consider several factors beyond the demand load. These factors include the voltage of the service, the ambient temperature, the type of wiring used, and the distance from the power source. The voltage of the service will affect the current that the system will draw. Higher voltages will result in lower currents, which can reduce the size of the conductors required. The ambient temperature can affect the ampacity of the conductors. Higher temperatures will reduce the ampacity of the conductors, which means that larger conductors may be required. The type of wiring used will also affect the ampacity of the conductors. Some types of wiring have a higher ampacity than others. The distance from the power source can also affect the size of the conductors required. Longer distances will result in a voltage drop, which can reduce the performance of the equipment. To compensate for voltage drop, larger conductors may be required. It is also important to consider the future needs of the car wash. If the car wash is planning to expand in the future, it is important to size the electrical service accordingly. This will avoid the need to upgrade the electrical service in the future. In addition to the NEC and ASHRAE Standard 202, there may be other local codes and regulations that apply to car washes. It is important to check with the local authorities to ensure that the electrical service is sized in accordance with all applicable codes and regulations. Here is a more detailed breakdown of the process. Firstly, determine the connected load. This involves identifying all electrical equipment in the car wash, including motors for pumps, blowers, conveyors, lighting, heating, ventilation, and air conditioning, abbreviated HVAC, systems, control panels, and any other electrical devices. Obtain the nameplate data for each piece of equipment. The nameplate typically lists the voltage, amperage, and power in watts or kilowatts. If the power is listed in horsepower, convert it to watts using the conversion factor of 746 watts per horsepower. Calculate the total wattage for each type of equipment. For motors, use the formula power in watts equals voltage multiplied by amperage multiplied by the power factor. The power factor is typically listed in the motor nameplate, but if it is not available, a typical value of 0.8 can be used. For resistive loads such as heaters, the power factor is 1.0. Sum the total wattage of all equipment to determine the total connected load. Secondly, apply demand factors. Demand factors are used to reduce the connected load to account for the fact that not all equipment will be operating at the same time. Demand factors are typically expressed as a percentage of the connected load. Consult ASHRAE Standard 202 for recommended demand factors for car washes. As mentioned earlier, the demand factor for automatic car washes is typically 60%, while the demand factor for manual car washes is typically 40%. Apply the appropriate demand factor to the connected load to determine the demand load. For example, if the connected load is 100 kilowatts and the demand factor is 60%, the demand load would be 60 kilowatts. Thirdly, calculate the service size. The service size is the total amount of power that the electrical service must be able to provide. The service size is typically expressed in amps. To calculate the service size, use the formula service size in amps equals demand load in watts divided by voltage multiplied by the square root of 3 for three-phase systems or divided by voltage for single-phase systems. For example, if the demand load is 60 kilowatts, the voltage is 480 volts, and the system is three-phase, the service size would be 72.2 amps, calculated as 60,000 watts divided by 480 volts multiplied by the square root of 3. Select the appropriate conductor size and overcurrent protection. The conductor size must be large enough to carry the service size current without overheating. The overcurrent protection, such as a circuit breaker or fuse, must be sized to protect the conductors from overload. Consult the NEC for the appropriate conductor size and the overcurrent protection for the calculated service size. Consider voltage drop. Voltage drop is the reduction in voltage that occurs as electricity flows through the conductors. Excessive voltage drop can cause equipment to malfunction or fail. The NEC recommends that voltage drop be limited to 3% for branch circuits and 5% for feeders. Calculate the voltage drop for the proposed conductor size and length. If the voltage drop exceeds the recommended limits, increase the conductor size. Coordinate with the local utility company. The local utility company will need to approve the electrical service design before it can be installed. The utility company will also need to provide the service connection. Provide the utility company with the calculated service size and the proposed electrical service design. Obtain all necessary permits. An electrical permit is typically required before any electrical work can be performed. Obtain the necessary permits from the local building department. Have the electrical work inspected. Once the electrical work is complete, it must be inspected by a qualified electrical inspector. The inspector will verify that the electrical work was performed in accordance with the NEC and local codes. Here is an example calculation. Assume a car wash with the following equipment. 1. A wash motor rated at 15 horsepower, operating at 480 volts, 3-phase, with a power factor of 0.85. 2. A blower motor rated at 10 horsepower, operating at 480 volts, 3-phase, with a power factor of 0.83. A water pump motor rated at 7.5 horsepower, operating at 480 volts, 3-phase, with a power factor of 0.75. 4. Lighting with a total load of 3 kilowatts. 5. A heater with a total load of 5 kilowatts. Firstly, calculate the connected load. Wash motor 15 horsepower multiplied by 746 watts per horsepower equals 11,190 watts. Blower motor 10 horsepower multiplied by 746 watts per horsepower equals 7,460 watts. Water pump motor 7.5 horsepower multiplied by 746 watts per horsepower equals 5,595 watts. Lighting 3,000 watts. Heater 5,000 watts. Total connected load 11,190 watts plus 7,460 watts plus 5,595 watts plus 3,000 watts plus 5,000 watts equals 32,245 watts, or 32.245 kilowatts. Secondly, apply demand factors. Assume the car wash is an automatic car wash with a demand factor of 60%. Demand load 32.245 kilowatts multiplied by 0.6 equals 19.347 kilowatts. Thirdly, calculate the service size. Service size in amps equals 19,347 watts divided by 480 volts multiplied by the square root of 3 equals 23.25 amps. Select the appropriate conductor size and overcurrent protection. According to NEC Table 310.15, B16, a 23.25 amp load requires a minimum of 12 American wire gauge, abbreviated AWG, copper conductors with a 30 amp overcurrent protection device. Verify voltage drop. Assume the distance from the service entrance to the farthest load is 100 feet. Using a voltage drop calculator, the voltage drop for 12 AWG copper conductors carrying 23.25 amps over 100 feet at 480 volts is approximately 1.5%, which is within the recommended limit of 3%. Therefore, 12 AWG conductors are sufficient. Service size calculation provides a minimum value. It is prudent to add a safety factor of 25% to account for future expansion or unforeseen loads. In this example, adding a 25% safety factor would increase the service size to approximately 29 amps. This would require upgrading the conductors to 10 AWG copper conductors with a 35 amp overcurrent protection device. Always consult with a qualified electrician or electrical engineer to ensure that the electrical service is properly sized and installed in accordance with all applicable codes and regulations. Additionally, consider the starting current of motors. Motors draw significantly higher current when starting than when running at full speed. This starting current, also known as inrush current, can be several times the full load current. The electrical service must be able to handle the inrush current of all motors that may start simultaneously. The NEC provides guidance on sizing conductors and overcurrent protection for motor circuits, taking into account the starting current. It may be necessary to use larger conductors and overcurrent protection devices than would be required based on the full load current alone. Furthermore, harmonics can be produced by nonlinear loads such as variable frequency drives, abbreviated VFD, which are commonly used to control the speed of motors in car washes. Harmonics can distort the voltage and current waveforms, leading to increased heating of conductors and equipment, as well as other problems. If VFD are used, it may be necessary to install harmonic filters to mitigate the effects of harmonics. Surge protection is also an important consideration. Car washes are often located in areas that are susceptible to lightning strikes or other voltage surges. Voltage surges can damage sensitive electronic equipment. Surge protection devices, abbreviated SPD, should be installed at the service entrance and at any sensitive equipment to protect against voltage surges. Grounding is critical for safety. A properly grounded electrical system provides a path for fault current to flow back to the source, which helps to trip over current protection devices and prevent electrical shock. The grounding system should be installed in accordance with the NEC. Regular maintenance is essential for ensuring the safe and reliable operation of the electrical system. Regular maintenance should include inspecting conductors for damage, tightening connections, testing overcurrent protection devices, and cleaning equipment. A qualified electrician should perform regular maintenance. Documentation is important. Keep accurate records of all electrical equipment, including nameplate data, wiring diagrams, and maintenance records. This information will be helpful for troubleshooting problems and for planning future upgrades. In addition to the technical aspects of sizing the electrical service, it is also important to consider the cost. The cost of the electrical service will depend on the size of the service, the type of equipment used, and the labor costs. Obtain multiple bids from qualified electrical contractors to ensure that you are getting a competitive price. The energy efficiency of the electrical system can also impact the operating costs of the car wash. Consider using energy-efficient motors, lighting, and other equipment. This can reduce the energy consumption of the car wash and lower the electricity bill. Rebates and incentives may be available from the local utility company for installing energy-efficient equipment. The National Electrical Manufacturers Association, abbreviated NEMA, provides standards for electrical equipment. Ensure that all electrical equipment used in the car wash meets NEMA standards. Safety is paramount. Always follow safe electrical practices when working on or around electrical equipment. De-energize equipment before working on it and use appropriate personal protective equipment, abbreviated PPE, such as gloves and safety glasses. If you are not qualified to work on electrical equipment, hire a qualified electrician. The location of the car wash can also affect the electrical service requirements. For example, car washes located in areas with high wind speeds may require special grounding and bonding to protect against lightning strikes. Car washes located in areas with corrosive environments may require special corrosion-resistant materials. The type of car wash can also affect the electrical service requirements. For example, self-service car washes may have different electrical requirements than automatic car washes. Self-service car washes typically have multiple bays, each with its own set of equipment. Automatic car washes typically have a single bay with a conveyor system that moves the vehicle through the wash process. The electrical service must be able to handle the load of all of the equipment in the car wash. The hours of operation of the car wash can also affect the electrical service requirements. Car washes that operate for long hours will have a higher energy consumption than car washes that operate for shorter hours. The electrical service must be able to handle the peak demand of the car wash during its hours of operation. The number of employees at the car wash can also affect the electrical service requirements. Car washes with more employees will typically have a higher demand for lighting and other electrical equipment. The electrical service must be able to handle the load of all of the electrical equipment used by the employees. The type of customers that the car wash serves can also affect the electrical service requirement. Car washes that serve a large number of commercial vehicles may have different electrical requirements than car washes that serve primarily passenger vehicles. Commercial vehicles typically require more powerful washing equipment. The electrical service must be able to handle the load of the more powerful washing equipment. The age of the car wash can also affect the electrical service requirements. Older car washes may have electrical systems that are not up to current codes. The electrical system may need to be upgraded to meet current codes. The condition of the electrical equipment can also affect the electrical service requirements. Worn or damaged electrical equipment may draw more current than new equipment. The electrical system may need to be repaired or replaced to improve its efficiency and safety. Future expansion plans should also be considered. If the car wash is planning to expand in the future, the electrical service should be sized to accommodate the future expansion. It is better to oversize the electrical service now than to have to upgrade it later. The budget for the electrical service should also be considered. The cost of the electrical service can vary depending on the size of the service, the type of equipment used, and the labor costs. It is important to get multiple bids from qualified electrical contractors to ensure that you are getting a competitive price. The availability of financing should also be considered. Financing may be available for the electrical service from a variety of sources, such as banks, credit unions, and government agencies. The terms of the financing should be carefully reviewed before making a decision. The reputation of the electrical contractor should also be considered. Choose an electrical contractor with a good reputation and a proven track record of quality work. Check references and read online reviews before making a decision. The warranty offered by the electrical contractor should also be considered. Choose an electrical contractor who offers a good warranty on their work. The warranty should cover both materials and labor. The insurance coverage of the electrical contractor should also be considered. Choose an electrical contractor who has adequate insurance coverage to protect you from liability in case of an accident. The licensing of the electrical contractor should also be considered. Choose an electrical contractor who is properly licensed to perform electrical work in your area. The safety record of the electrical contractor should also be considered. Choose an electrical contractor who has a good safety record. The environmental practices of the electrical contractor should also be considered. Choose an electrical contractor who follows environmentally sound practices. The communication skills of the electrical contractor should also be considered. Choose an electrical contractor who communicates effectively and keeps you informed of the progress of the work. The problem-solving skills of the electrical contractor should also be considered. Choose an electrical contractor who is able to solve problems quickly and efficiently. The attention to detail of the electrical contractor should also be considered. Choose an electrical contractor who pays attention to detail and ensures that the work is done correctly. The customer service skills of the electrical contractor should also be considered. Choose an electrical contractor who provides excellent customer service and is responsive to your needs. Considering all of these factors will help to ensure that the electrical service for the car wash is properly sized, installed, and maintained. This will result in a safe, reliable, and efficient electrical system that will meet the needs of the car wash for years to come. Remember to consult with qualified professionals, including electricians and engineers, throughout the process to ensure compliance with all applicable codes and standards. Florida's climate considerations also impact electrical service design, requiring attention to heat and humidity. Select equipment rated for high ambient temperatures and implement measures to mitigate heat buildup in electrical panels. Use corrosion-resistant materials for wiring and enclosures to withstand the humid environment, and ensure proper ventilation for electrical rooms to prevent overheating and condensation.